Hi, we want to understand industrial networking and the advantages of using field bus coupled with the IO-Link interface. In our exercise, we will be using a Profibus field bus system along with various IO-Link interface modules in order to expand the amount of actuators and sensors that we can interface with in the field. The advantages and benefits of using field bus and IO-Link are realized in terms of money saving. Right at the stage of installation, when the machine is being produced, the simplicity of the IO-Link and the field bus system helps in quicker production, smaller area and larger turnaround time. When the machine is running, the maintenance features, diagnostic features, as well as the long periods during which you do not need maintenance help in making it very easy for the team to manage and locate errors while the machine is in production. In operation, the machine is highly efficient. Sensors can be used right at the place of their action, and time can be optimized due to faster data transmission. The final saving is realized from the uptime of the machine, as the machine is more and more into production and with very few downtime problems originating from either maintenance or operation. My name is Raul Rodrigues, and you can contact me anytime if there is any inquiry, any requirements, any queries, any doubts. Please feel free to call me. For our exercise, we are going to use a PLC from Siemens, which includes a Profibus master. We're going to have a dedicated power supply for the PLC, and we would be using Simatic Manager Step 7 software for completing the configuration settings. We will use an external power supply for the rest of our network, including various cables for power, for connections, for Profibus, and we shall use another set of cables for connecting the IO-Link field modules as well as the other actuators and sensors. A summary of what we are going to use is put out over here in case you require to access more detailed information of each of the modules. In our exercise, we shall begin with a smaller part of the complete, and then we shall proceed step by step. An industrial network basically consists of 3 levels. The top level is called the PLC or the field bus master level. Then you have the field bus level. In our case, since it is a Profibus exercise, we call it the Profibus level. And then finally we have the IO-Link and field devices level. You could split this into IO-Link level and field devices level, but for us we are putting them into one category. The PLC and the Profibus master level begins with the rail on which all the modules of the PLC, including the PLC CPU, can be mounted. Right on slot number 1 is usually the prominent position for the power supply for the PLC. In our case, on slot number 2, we have the CPU of the PLC, which includes a Profibus master, both occupying slot 2. You may have other modules in your PLC, like various other input-output modules, which are not particularly relevant to our discussion and exercise, and so we shall not spend too much time on this. Then we require a communication interfacing device, in our case a laptop, which we can use for uploading the programs to the PLC. We have chosen to use an external power supply for the rest of our network. The first Profibus slave that we will be using, in our case, is a Baluf module. We will use a power distributor or a power T or a power splitter as it is called, in order to tap power from the power supply and feed it to the various modules that require power. So as you can see, we have powered up our first mass slave. The slave that we have here is capable of outputs and inputs, and with special features for the last 4 ports, which have the additional capability of IO-Link expansion. Right now on port number 1 we have connected our first field device, which happens to be an input. In our case, you can consider it to be an inductive sensor. We are using a Y connector or a splitter, which gives us access to the IO-Link port on port number 5. The Y connector gives us access to pin 4 and pin 2. Pin 4 is brought down here and we can connect an IO-Link device to it. Pin 2 is an additional input for us. In our case, we can use some other kind of input sensor. On port number 6 we are connecting an IO-Link sensor hub, from where we can connect further sensors and expand our network. So we have another input connected here. On port number 7 we are going to connect another IO-Link sensor hub, but this time we are going to use an inductive coupler. The inductive coupler consists of a base and a remote, and actually completes the continuity of the cable, however physically without any connections. We shall have a look at this a little later. And finally we get the connection to the sensor hub, and from the sensor hub we can connect an additional input sensor. The power for the sensor hub as well as the power for all the connected devices come through the remote, through the air gap, and from the module and through the power supply. So basically we are able to transmit power, we are able to transmit input information across an air gap by using the inductive coupler. This makes it very useful for applications where there is rotation or any kind of motion with relevance to the base station. We are going to also connect an output on port number 0. So that's an output on port number 0, happens to be a simple relay. And finally we make the Profibus connection to the master. We will then configure all this information in Simatic step 7 using our laptop, and then upload this information to the PLC, thereby giving all the relevant information that is required by the PLC in order to run the program. In the next exercise, we shall continue to expand this network by tapping power from the power T or by transferring power from the power out, and we can expand by using the bus out terminal so that we can go on to the next bus slave and further. Each bus slave, as you know, would require an address. For proper configuration of the bus slaves, you also require the GSG files in this case. So make sure you have the GSG files of each of these devices that you want to put on the network. Make sure you have identified what kind of address you want to give it. The Profibus system can give you addresses from 0 to 125. So just allocate some kind of addresses that you plan to give. As far as the IO-Link devices are concerned, make sure you have the input output process data information, because this is required for configuration. Make sure you also have the IODD files, which basically is a description of the device. These will help in setting up our configuration much faster. So we shall go on to understand the same layout in a simpler form and how it would look in the real world.